Hello, friends. Welcome to Scale Up University. Welcome to lecture number 2 of this course on building human level AI grading systems. So, in this course, basically, we will be learning how to build a human level AI grading system. And this is the lecture number 2 of this course. And in this lecture, we will be talking about what this course is exactly about and what it is not about. So this lecture will give you a clarity on what exactly we will be discussing in the subsequent lectures, what this course is about. So this lecture will draw clear boundaries. So if we look at the topics we will be looking at in this lecture, so first we will be looking at the problem we actually solve, like the problem which we will be dealing with in this course, that we will discuss. Then we will look at the problem we do not solve. So the domain or the problem which we will not be focusing on in this course, that we will discuss. Then we will compare human level accuracy with human level reasoning. Then we will be looking at practical classroom constraints. Like in any classroom, in the real world setting, there are some constraints are there. That's the reality check that we will be doing. And then we will be looking at how this course differs from generic AI in education content. Like this course is different from a generic AI in education content, and how it is different, that we will discuss. And in the end, we will conclude this lecture. So these are the topics we will be looking at in this lecture one by one. So we'll start straight away with the first topic, that is what problem we actually solve. So the precise problem statement. So we have a specific, tightly defined problem statement that we will be talking about, and that is how can we accurately and consistently classify short answer constructed responses at scale using minimal labeled data while remaining practical for real classrooms. So basically, the precise problem statement is like a specific, tightly defined problem which we will be focusing in on this course. In this course, basically, that is how can we accurately and consistently classify short answer constructed responses at scale? Because in this course, we will be building AI grading system, like AI powered grading system, and that will be for short answer constructed responses. Because see, for multiple choice questions, MCQs, we already have grading systems. There is no need for AI to solve that problem. But if I talk about subjective solutions, where long answer constructed responses or short answer constructed responses are involved, there we cannot automate it via traditional setting. There AI comes into the picture, and with the power of AI, we can do the assessment of it. We can grade it at scale. So in this course, we will be focusing only on the short answer constructed responses and not the long answers. So our goal is very clear. We will classify short answer constructed responses at scale using minimal label data, because here we will be using near domain data, and hence we will be using a very small amount of label data. And our solution should be practical for real classroom settings, like whatever model we will be building, it should be effective in grading short answer constructed responses for a real classroom setting. So that's the precise problem statement we will be focusing to solve in this course. So as we saw in the problem statement, we are talking about short answer constructed responses. So we are talking about short answer grading. So what exactly short answer grading means here? So let us look at that. So let us be very clear. We are not grading essays. We are not grading creative writing. We are not grading long form arguments. So let us be very clear. Whatever AI powered grading system we will be making, that will not be grading essays, that will not be grading creative writing, nor it will be grading long form arguments. Rather, we will be grading short constructed responses, which are typically 1 to 5 sentences, which are focused on content understanding, not writing quality, and which is common in STEM, science, technology, engineering, mathematics, biology, physics, engineering, and foundational courses. So basically, in this course, the AI powered grading system we will be making, it would be good in grading short constructed responses. So the responses would be typically 1 to 5 sentences long, and the focus will be on content understanding and not writing quality. So the AI grading system will not assess the writing quality, rather it will assess the what has written, the content, content understanding, and the field will can be like our AI, we can train it in the field of STEM, biology, physics, engineering, and foundational courses. Now, if we talk about the core constraints in a real classroom setting, instructors do not have thousands of labeled responses per question. So it's like quite obvious that instructors do not have thousands of labeled responses per question, because if I talk about a subjective question like short constructed responses, so for every question the answer can be different, the way of expression, the way of writing, it might be different. But unfortunately instructors do not have thousands of labeled responses per question, but instructors do have data from similar questions asked in previous year. And here is what near domain data comes into the picture, because we will not be having thousands of labeled responses, rather we will be having data from similar questions. So near domain data, it talks about can we reuse that prior knowledge intelligently. Like we have prior knowledge of similar questions asked in the previous years. Can we make use of those questions to create a AI based grading systems for short responses? So that is the near domain data. So can we make use of the near domain data? Because as it is evident from the discussion in this course, whatever AI model we will be making, it will not be making use of thousands of labeled responses, but rather it will be making use of near domain data. So this is the core constraint we have to keep in mind. Like whatever AI model we will be building, it will be focused on the principle of near domain data. And the core constraint is that only, that our AI model will be relied on near domain data, and we are not being given, or we don't have large data sets, thousands of data sets, and that's the core constraint. Now the research demonstrates that models trained on related questions can perform well on new questions. So models trained on related questions can perform well on new questions which is related to those questions on which model is trained. Only a small fraction of new label data is needed. Now research has demonstrated that near domain data, that is models trained on related questions, can perform well on new questions, and hence only a small fraction of new label data is needed. We don't need thousands of data sets. Only a small fraction of new label data is enough. And the most important point, according to the research, accuracy can reach human level agreement. This is something which is very, very big, because research has demonstrated that if we try to build a AI powered grading system for short response questions, and if we train the model on near domain data, we can reach human level accuracy. And this is something which is motivating us. It's a light. It's a very big motivation and inspiration for us, that in this course, in the subsequent lectures, you will see we will be building something really, something which will really have an impact in the education field. So this research, it makes automated grading feasible, affordable, and deployable. So this is something which makes automated grading feasible, affordable, and deployable. Now we will talk about what problem we do not solve. So this course is not about AGI or general artificial intelligence. So the AI enabled grading system which we will be making. So this system does not understand biology like a human. This system does not reason casually in a human sense. This system does not discover new concepts. So the system, the AI system, the AI grading system which we will be making, it will not discover new concepts. It will not reason casually in a human sense. It will not understand biology like a human does. And it does not replace subject matter expertise. So the system which we will be making, it performs statistical pattern recognition guided by labeled examples. So whatever AI grading system we will be making, it will be guided by labeled examples, and it will just perform statistical pattern recognition, and based on that, it will be doing the grading of short response questions, and it will not be any artificial general intelligence. So we have clearly defined the scope of the project or of the AI model which we will be building in this course. This is not autonomous teaching. In this course, we will not be talking about an AI which will be teaching autonomously. No. So the AI system, the AI grading system which we will make, that does not design curriculum. The system does not decide learning goals. The system does not modify pedagogy. The system does not judge student motivation or effort. So now it's very clear the scope, that whatever AI grading system we will be making, it will not at all involved in designing curriculum, deciding the learning goals, or judging students. These all will still remain human responsibilities. So human responsibilities taken care by humans. So the system which we will be making, the AI grading system, it is not bias free by default. So there can be bias in our AI model. So the idea is, it depends on the quality of the training data. If the training data contains ambiguity, if the training data contains inconsistent human grading, and if the training data contains domain specific assumptions, then definitely model will reflect those realities. So quality of training data matters. If training data contains ambiguity, if it contains inconsistent human grading, it contains domain specific assumptions, those will certainly be reflected in the model. So the idea is, AI does not eliminate bias. AI does not eliminate bias. If training data is biased, it will be reflected in the AI model. It will just stabilize whatever bias exists. So it stabilizes whatever bias exists. And one more very important point, like whatever AI grading system we will be making, it will not be universal across all subjects. It will be domain specific, it will be subject specific. For different subjects, we have to train different AI grading system models. So in this course, we'll focus on one domain, and that domain is basically central dogma in biology. So this course will focus only on one domain that is related to biology. This course demonstrates transfer within a domain, and this course does not claim universal cross-discipline performance. So we have clearly defined the scope of the course, wherein we have clearly specified that this course is not about artificial general intelligence. This course is not about autonomous teaching. This course is not about bias-free AI models. And this course is not about building AI model which will be universal across all subjects. So the idea is generalization must be tested, not assumed. So generalization must be tested, not assumed. Now we'll look at the next topic of this lecture, that is human level accuracy versus human level reasoning. So first, what exactly we mean by human level accuracy? So it is very clear to us that human grading in itself is not perfect. So in a study, human graders agreed around 80% of the time. Like around 80% of the time, graders agreed with each other's answers. There were disagreements for about 20% times, and these disagreements were common on borderline answers. So the idea is that human grading itself is not perfect. Like around 80% of the time, human graders agreed with each other's answers or responses, but there were disagreements also, and the disagreements were common on borderline answers. So when we talk about human level accuracy, it means matching expert agreement, not achieving perfection. So human level accuracy means AI should match expert agreements and it should not focus on achieving perfection. So we can say that if AI agrees with humans as often as humans agree with each other, we can say that AI is performing at human level. So human level accuracy for AI means AI should match with humans, like it should match with expert agreements, and it's not about achieving perfection. Now if we talk about what AI is actually optimizing, so the AI model optimizes consistency. The AI model optimizes pattern alignment with labeled examples. The model optimizes statistical similarity to prior judgments. So here prior judgments refer to previous assessments. Like we saw na related questions. So in near domain data, we talk about related questions. So the assessments of those related questions, that's a prior judgments. So the model will try to optimize the statistical similarity to prior judgments, pattern alignment with labeled examples, and consistency. The model does not form mental models. The model does not reason step by step casually. And the model does not understand meaning in a philosophical sense. So the AI model will be building, it will not form mental models, it will not reason step by step casually. It does not understand meaning in a philosophical sense. Now, why the distinction between human level accuracy and human level reasoning is important? So, it is important to avoid overtrust, because overtrust is AI understands students, which is wrong actually, because the AI model will be making it will not understand student. So we should not overtrust. We should avoid overtrust, because our AI model is not forming any mental model. It is not reasoning step by step. So it cannot understand students, the AI model which will be building. And to avoid rejection, that is, AI does not think like human. So see, the idea is that the AI grading system we will be making, certainly it will not be thinking like human. To be very honest with you, in this course, whatever AI model will be making, it will not think like human, and hence we have to avoid the rejection. Beforehand, it should be very clear to us that the AI grading system will be building, it will not think like humans. So that's why this distinction is important, human level accuracy versus human level reasoning. So our AI model will not be focusing on human like reasoning. Rather, it will be focused on human level accuracy, wherein whatever results it will be getting, it will be aligned with the human experts. It will be in agreement with the other humans. So in our scenario, our AI grading system, AI will match outcome, like the statistical similarity, and AI will not match cognition, that's thinking. So that's why this distinction is important. Okay, now we will be looking at the next topic of this lecture 2, that is practical classroom constraints. So we'll look at the constraints which instructors actually face. So we have time pressure, we have limited TA support, like teaching assistant support. We have fixed semesters. Like if we talk about construct constraints instructors face, institutional rules and ethical responsibilities. So these are the constraints which an instructor face. Now the idea is that any system that ignores these constraints will fail, no matter how accurate it is. So despite the accuracy of the system, if the system ignores these constraints, then certainly the system will fail. Now we'll talk about design principles derived from reality. So this course intentionally avoids requiring handcrafted rubrics. This course avoids requiring handcrafted rubrics means this the AI model which we will be making, it is not like it will follow fixed rules, or it will be needing some specific fixed techniques. Rather, it will be flexible, it will be adaptable, and the AI model which will be making, it avoids massive labeling efforts. Actually, we won't be needing huge data set. Only near domain data is suffice. So the AI system, the AI grading system which we'll be making, it avoids exotic hardware requirements. And AI grading system, it works with existing historical data. So the design principle of our AI system, AI grading system, is derived from reality, wherein it will focus on simplicity and not complexity. So the goal is adaptability, not novelty. Like we will not be focusing on building something novel, something very out of the box, something very new. Rather, we will be focused on building a AI grading system which is more realistic, it is adaptable, it can fit the real world classroom setting. That's the main objective. That's a design principle we are talking about. So the design principles for our AI grading system is derived from reality. If we talk about why small models matter, so for large models, they are expensive, they consume massive energy, they require cloud dependency for GPUs or some hardware infrastructure, and large models are difficult to audit. If we talk about smaller models, then you'll see that they are easier to deploy, they are more transparent because they're less complex, they are environmentally responsible because they'll consume less energy, and they basically fit institutional budget, like they are less expensive. So all these factors, they make smaller models the fit choice, the right choice. And in this course, we will be focusing on smaller models only. The AI grading system which we'll be making, it will be a sort of smaller model. Now we'll look at the next topic of this lecture, that is how this course differs from generic AI in education content. So what generic AI in ed content often does. So you might have heard about so many hypes which talks about AI revolution, like how AI is revolutionizing educational content. So typical content, if I talk about, it demonstrates flashy demos. It uses vague claims like AI will transform education. It focuses on tools, not theory. It avoids error analysis and it ignores deployment realities. So we have seen so many hypes like AI will transform education, like vague claims. So basically, those claims they demonstrate flashy demos, which does not have any ground reality. It focuses on tools, not theory. It avoids error analysis. It ignores deployment realities. Now, how this course is different? So, what this course does differently? So, see, this course is not about any hype, but it is about building a AI grading system which is very much feasible, which will have human level accuracy. So, this course starts from a real educational problem. This course uses peer reviewed research. This course emphasizes limitations and failure modes. This course, the AI grading system which we'll be making, it analyzes errors, disagreements, and ambiguity. This course, the AI grading system, it balances accuracy with ethics and sustainability. So basically, how this course is different, because see, as you know, in this course we will be building a AI based grading system, AI powered grading system, which will be based on a real educational problem. In this course we will not be creating any unnecessary hype. We will not like do any vague claim. Rather, whatever AI model we will be building, AI powered grading system, it will be solving a real educational problem. It makes use of some good peer reviewed research. It emphasizes the limitations and failure modes. It will not claim that we are making something magical. Whatever AI grading system we will be making, it will be having some limitations and failure modes, and we will be emphasizing on that in this course. And the AI grading system which will be making will be analyzing errors, disagreements, and ambiguities. And we will balance accuracy with ethics and sustainability. So now it's very clear to you that this course will be very genuine. Whatever AI powered grading system we are making of human level accuracy, it will be worth it. So finally, we are about to conclude this lecture. So now, uh, like, I hope you got a very clear understanding about the scope of this course. This course is not about automating education. Rather, it is about supporting learning at scale without losing human judgment. So basically, in this course, we are not going to replace any instructor, any professor, or any educator. This course is not about automating the content delivery, automating the education. Rather, it is about AI powered automated grading with human level accuracy. So it is about supporting learning at scale by grading short response questions without losing human judgment. Because with human level accuracy, we can automate constructed response questions like subjective questions. We can automate subjective questions. And that is the goal of this course. Because in this course, we will be building AI powered grading system with human level accuracy. So friends, finally we completed lecture 2 of this course. I hope you liked this lecture. So do subscribe to this YouTube channel for more such interesting courses and lectures. Also share it in your circle, share it with your friends. If you have anything to discuss, you can drop in a comment. So thanks for watching. Thanks for your time.